Hi everyone. I'm Shyam Prasad, and I'm going to discuss about access control and ID mapping on the Linux SMB client. Um, yeah, let's get started. Yeah, so a bit about myself. I currently work with the Azure Files team in Microsoft, and I am a contributor to the Linux SMB client file system project, the Linux project. A bit about the agenda today. I'm just going to cover a few basics about a few concepts, authentication, ID mapping, access control, with respect to the SMB client, and describe the various ways in which you can configure the SMB clients in order to achieve this. So some basic SMB file system concepts. So the file server or the service, the software stack that is sharing the files over the network. File client is a consumer of the file shared files. A software stack that communicates with the server and exposes the shared files. And then you have the concept of ID mapping, which basically the server understands the users that the admin has configured on the server, but not the client. So when the SMB client accesses the file share from the client, you need to map the client users to the server user. So this is the concept of ID mapping when it comes to SMB. Uh, and then you have the authentication and authorization, which is like common to most file systems. So let me go on to the next slide. So let's talk about authentication on the Linux SMB client. So the Linux SMB client today supports two forms of authentication, which is NTLM v2 and Kerberos based authentication. Um, the central part of the this is the kernel module cifs.ko, and it caches the credentials in the Linux key service, which contains both the Linux kernel as well as the user space stack. There is some difference when it comes to how the authentication happens on NTLM versus Kerberos. So on NTLM, you have the user credentials in the form of username and password that are entered into the Linux key service, and these credentials are then used by the cifs.ko to authenticate with the file server directly. But when it comes to Kerberos, the process of authentication is a two-step process where uh, the users will authenticate with the Kerberos authentication server in advance and collect the authentication token. And these are the intermediate token that the Kerberos server gives you, also called the Kerberos TGT, is what is used as a credential by the cifs.ko during the actual transfer. Uh, yeah, so also important is the for Kerberos, the there is a user space callback that happens from the kernel when the credential when a credential for a new user comes up. It calls up into user space, and you have a user space utility call that listens for the request from the kernel, and you can configure binbind or triple SD uh, uh, to delegate this task of keeping the authentication token up to date. So let me describe. a bit about how this happens. So this is about the a pictorial representation of the authentication flow for NTLM. So you have the file that contains the credentials during the mount, and the mount helper mount.cifs uses these in order to perform the mount system call. So the cifs.ko receives this and authenticates with the file server directly. And you have this another user space utility called cifscreds, with which you can, for certain scenarios, you can enter you like new users that can access the same mount, and this can be done using the cifs creds. And what essentially it's going to do is enter these credentials into the Linux key service, so that cifs.ko, when the user accesses the file share, the cifs.ko will look this up in the Linux key service, get the credentials, and use that for the authentication. Uh, in terms of the Kerberos authentication, again, what I had put in text, I'm showing that as a pictorial representation here. Winbind, you can configure Winbind and SSSD to authenticate with the Kerberos authentication server and get the Kerberos TGT, and this is put into the credential cache. So this process can also be manual, where you can simply do a K in it and get authenticated with the server and get the TGT. The only the one real advantage with the offloading this to Winbind is it has the feature of keeping this tickets up to date by refreshing them when needed. So the rest of the call is similar to NTLM, where you get you get the users accessing the file share, and cifs.ko will now look up the credentials from the Linux key service. When it doesn't find it, it upcalls into Userspace. The Userspace collects this the TGT from the credential cache, gives it back to the kernel, and the kernel uses this for the next level of authentication. Then on how the ID mapping happens in the Linux SMB client. So ID mapping is, as I said, mapping between the local users on the client to the remote users, that is the users on the server. So there are a couple of challenges here, which in so one of the challenges is that since you have multiple, you can have multiple Linux clients that are accessing the same file share. An SMB user that is logged into each of these Linux clients can have a different UIDs, the user IDs on each of these clients. However, the ID mapping is to ensure that all of them map to the same server ID. And the second challenge is where you have different users that are logged into different clients, and it should not so happen that you have the same, you can have the same UID for different users on different VMs, and it should the ID mapping subsystem should take care to see that the server IDs are different for these different users, or else you can have like one user read data from the other, which is not desirable. Uh, so this becomes relatively simple with the presence of central LDAP service, which manages this identity mapping. And if this so one of the things that gives us is Active Directory, which For example, Windows and Samba Active Directory do support something called RFC 2307, which allows adding attributes to Active Directory user objects to to have the mapping on the LDAP server itself. So how does the Linux SMB client manage all this? So again, it delegates the task to user space utilities, where the kernel module, just like we cache the credentials for the user, there's also ID mappings that are cached in the kernel service, the Linux key service, and when there is a cache miss, that is a particular mapping is not available, it calls up into user space, and in the user space there's a utility called cifs-id-map, which performs the mapping. So today, again, it's quite beneficial to configure this ID map to use a WinBind or a triple SD plugin, and simply use the APIs that they offer in order to do the LDAP queries to the Active Directory. So another thing that, as I said, the RFC 2307 is supported on both Windows domain controller as well as Samba domain controller. So uh, both WinBind and Triple HDs are equipped to use a query for these on these servers, and essentially do the mapping between the SIDs and UIDs and GIDs on Linux. So yeah, I'll cover more on what SIDs stand for in further slides. So again, this is a pictorial representation where you have the cifs.ko upcalling to user space where the ID mapping happens, and yeah. Next is how all these binds together into access control, which is nothing but authorization on the client. So again, what is file system access control in general for file system is that when accessing a file system, a user is associated with one or more identities, and these identities may relate directly to the user or to a group of users, and you have certain metadata tagged with the file system objects, the files and directories, uh, which contain the permissions granted to uh, particular users or a group of users. And how does this map to the Linux file systems in general? So on Linux, you have every process that is running on Linux is associated with a UID and a GID. You have the file system objects, again, that contain the UID GID pair for the file ownership, file and directory ownership, and you have the mode bits, which describe the permissions of the authorized users. So uh, as you can see, there is these mode bits have are very broad by nature, in the sense that you can set read, write, and execute permissions mainly for three set of users: user, group, and others. User being the owner, user group being the group owner, and others being everyone else. So there is only limited granularity of access control that are possible with the more bits. However, this is a way that Linux has evolved traditionally. Although quite relatively recently, Linux has started supporting POSIX ACLs that allow a bit more granular control over the access rules. So how access control works in SMB protocols? So SMB has mainly evolved from the Windows NTFS file system. So as a result, it uses the NT security descriptors for access control. So security descriptor contains a list of access control entries which specify permissions to apply to different group of users. And when it comes to ownership information for both for users and groups, NT-ACLs make use of something called SIDs, the security IDs. And these NT-ACLs are sometimes referred to as rich ACLs because they offer much more finer access control with the kind of rules that they can specify. So in addition to you not only have allow or deny permission, you also have inheritance, uh, so this is much more finer access control compared to POSIX ACLs. However, can get quite confusing if there is a good number of access rules for a file. So in terms of SMB protocol, SID of a user is associated with every SMB session. So what SMB session is generally a connection between a client and a server for a particular user in the context of a user. And this is and this happens when a session is established, and before a session is established, a user gets authenticated, and only when with successful authentication does session get established for the SMB session. So in terms of SMB session handling on the the Linux SMB client, you have the UID GID pair associated with every SMB session, and along with that, you have a remote user associated with the SMB session. You can have multiple SMB sessions that is using the same client mount point, the file share mount point, and that is where you allow multiple users to access the same mount point, and this is done using the multi-user mount option. So this is a feature that of the Linux SMB client that allows you to do that. So in terms of the access control, there are three main types of access control that cifs.ko offers. The default is the server enforced access control. This is where the server completely enforces the access control, and the client really does very little in terms of checking for access. The second is the client enforced access control, where the client mainly does all the access control, and the server is the server really doesn't do any access control for this type. And then you have the hybrid, which is the cifsacl, which is more suitable for environments containing both Windows and Linux clients accessing the same file share, and you can have the mode bits and the ACLs translated and kept as a part of the SMB ACLs. So I'm going to describe each of this in the coming slides. So for the server enforced access control is the one that is most compatible with the SMB protocols. So even with the within the Linux client, you end up using the NT security descriptors and the ownership SIDs for the access control. And so for to use this, you need a file server which either supports the NT security descriptors natively, like the Windows servers do, or you need a server that will it doesn't have native support for NT security descriptors. However, does have a way of storing them and in a reversible format. For example, that's what the Samba file servers do. So one drawback with this type of access control is that for traditional Linux applications, which only understand mode bits and the UID and GID of the user, for the access control, this may not work. So that is the reason why we have the other modes of access control. The second one is where it is completely client enforced. So we have the IDs from SID and mode from SID mount option. Uh, so what this essentially means is IDs from SID will embeds the UID and GID of the Linux users within the SIDs in the NT security descriptors of every file. Mode from SID embeds the mode bits into the security descriptors as well. So as a result, you have a persistent way of storing the Linux attributes into the files on the file share. Uh, so one thing is that the server completely skips the access check for these files and directories. The reason being that the SIDs the SID range that we use for embedding these attributes in there is it uses the reserved range, and it is not the access check is simply skipped by the server. Again, this is suitable only for environments where there is Linux exclusively Linux clients and no Windows clients or non-Linux clients. So one word of caution with using these mount options is that you need to ensure that the UID and GID for all the users and groups on these on the Linux clients that access the file share remains the same in all the clients that access it. So one way to ensure this is with the use of WinBind and Active Directory. There are options that allow you to ensure that the UID GID remains the same for no matter what the Linux client is used. So this has been introduced in the fairly new Linux kernels, which is 5.8 onwards, and not be available to the older kernels. We come to the cifsacl way of access control, mainly the translation between the Linux world and the Windows NTFS world. What this one does is that similar to the previous option, it stores the Linux attributes, the mode bits and the UIDs, GIDs into the security descriptors. However, it is not embedding those. Instead, it is translating them to directly to what the corresponding NTFS format should be. So it tries to do this as closely as possible, although every unique anti-security descriptor may not correspond to may not be possible to directly represent them as Linux mode bits. This mode tries to emulate that as perfectly as possible, and yeah. So this is mainly desired when you want Linux clients to coexist with the Windows clients on an environment, and you have the one single file share being accessed by both Windows and Linux clients. So essentially, what you end up doing with this mode is that you translate the Linux mode bits into the corresponding permissions on the anti-security descriptor ACLs, anti-ACLs, and you also translate the UID, GID into owner and group SIDs and store it in the security descriptor. And hence, clients that are accessing from Windows clients will also be able to enforce the same like similar access control even on Windows clients without any modifications. So this is again particularly useful when mounting with the multi-user mount option, which I spoke about earlier, where you have multiple users accessing the same file share. This is a fairly new mount option that has been stabilized in Linux kernel 5.12, the upcoming the latest of the mainline kernels. And then I briefly touched upon a few of these user space utilities in the slides. Mount.cifs is a user space helper for calling the mount system call. And then you have the get cifsacl and set cifsacl. So these are utilities that help you to query or update the NT security descriptors, and also the which give you the DACLs as well as SACLs, which is mainly DACLs are for the permissions and SACLs are for auditing, and both of these are supported now with the get cifsacl and set cifsacl utilities. The next one is the SMB info, the Samba utility, which is another tool that displays like some of these information like security descriptors, and not only that, it is actually a superset of what it can do. So you have various other information about files that are available, files and the file share available to you with SMB info. And then you have the cifs threads, which I already spoke about, which is used to store NTLM credentials into the kernel keyring. And then you have a GUI tool that can be used for querying and managing the security descriptors on SMB from a Linux client. And these are the two user space helpers which I already spoke about for upcall and ID mapping. Okay, so with that I come to the last slide of this presentation. So the future work that is pending in this area, especially with the security features of the Linux SMB client. So there has been good work that has been going on over the last few years, but there's still a lot more to do in terms of coverage and any contributions from the open source community is welcome, and it can be very helpful. So in terms of the actual features that could be quite useful in this area, there is so NTLM and Kerberos have been around for as authentication protocols for quite some time, but there are newer protocols that have become quite popular, and a couple of notable ones involve PKUTU and OAuth. So we may need to. It'll be good to have support for these protocols in the SMB client. And then the next is to improve the regression testing for these security features. So although there is a framework framework which allows us to keep running regression testing, nightly regression tests on the latest branches, uh, it still lacks the test cases that are specific to SMB and not specific to Linux file system in general. So any new test cases that are added here for SMB specific features will improve the robustness of this code. And then we can talk about the reliance of the CIF stack on Winbind or Triple HD for mapping the IDs. On some simpler environments, customers may not want to install Winbind in order to have this. So one of all, we can have a feature that introduces a fallback mechanism, which simply maps has ID mapping in as simple as local config file. Again, more ideas on this can also be quite useful. There could be more other efficient ways of doing things. And then, as always, there is further scope of improvements with respect to the user space utilities, especially for dealing with ACLs. And there's still a lot of scope of improvement in terms of what features those can support. And then we can have added support for claims-based ACLs, which is a new NTFS-based ACL, which in addition to the permissions that are set based on the users that are accessing the files, you could have other factors like the location or time of access also considered for the access control. So we could add support for that as well into the Linux SMB stack. And then you have the SE Linux, which is which strengthens the Linux kernel and the whole system as a whole. And we still are not fully compliant with the SE Linux in terms of file system. So we'll need to add support for having full compliance for that. So that is also future work that is planned in this area. And the access control modes which I introduced in the previous slides, the mode from SIDS and cifsacl. So these have been fairly recently introduced. However, we may need to run performance profiling and analyze the performance of these mount options for large scale sets. And finally, the support for quick protocol. So, quick protocol is gaining interest in the developers of the Linux community, and when it becomes available to the Linux clients for production, the SMB client also needs to support the protocol in terms of the security features. For example, and when there is quick encryption over quick supported, do you really want to use SMB encryption? So we may need to fine tune SMB for specific to quick protocol in terms of the security feature. So yes, that brings me to the end of my presentation. Thank you, and I haven't checked the chat yet. If there are any questions, please feel free to ask. I'll be happy to answer.
So I know that Microsoft has a quick implementation, but I think it would be a lot of work to import in the kernel, and probably a lot of work to sort of adapt the style, I guess. Have you ever looked at this already?
Yes, so that is something that is ongoing currently, where like Stephen French is talking to a couple of developers within Microsoft in order to have this implementation ported to the Linux kernel, even if it's for developer preview. So that is as we speak, that is parallel conversation that is going on. So yeah, that is in progress right now.
If you do that, can you make sure that this is exported as a normal socket also to Userspace so that Samba could also use it?
Yes, I think so. It's at a very early stage right now. Yeah, but when that happens, we should ensure that these things are considered as well. Anything else?
So I was interested in the SE Linux work. That's very dependent on system extended attributes. So, and at least for a Windows server, extended attributes are case insensitive. I guess that probably doesn't matter. But I'm just wondering, what would that look like? Are you thinking of storing SE Linux tags on a file on a Windows server or something like that? What are your thoughts around that?
Yes. So these are the like bottlenecks when it comes to Windows based server in terms of case insensitivity. So these are something that needs to be tackled, and we can we can try to push for Linux compatible extended attributes. So again, this is something that still needs to be done, and it's not there yet.
Yeah, because there's no different in the Windows EA world. There's no different namespaces, so the difficulty would be any EA that you could set. Even as administrator, anyone with EA write access to the file could also change, which is not really what you want. So
Right.
I think it would probably need either a protocol change or some kind of file system modification in order to make that work. SE Linux is a nightmare. I've looked at this before, and SE Linux even has tags and extended attributes on symlinks, which is just a disaster. But anyway, sorry. Maybe you and I can talk about this offline.
Yeah, offline, there's a couple things to follow up on. Chuck Lever, I think, did the RFC, right, for NFS supporting this, right? Jeremy, you may remember if that was Chuck. But the NFS RFC for supporting SE Linux may have lessons we can learn, but I'm thinking that this is the kind of thing you do via special cifsacl, and if the server doesn't support it, it throws it away, just rejects it, because the security implications.
Yeah, that's a good idea, Steve, because trying to set it via the normal EA mechanism is probably a non-starter.
I mean, my only other thought that I was brainstorming about was you could use an alternate data stream, and the server could be required basically to handle it differently. But that has the same problem as EA's, right? Is that technically the server can screw up. And
yes, please don't use it. Please don't use data streams.
But I think doing it as an cifsacl is easy, because adding an cifsacl has zero risk to anybody.
I still hate data streams, so.
And by the way, the reason this becomes so interesting is that there are workloads that really do require SE Linux, and then on top of this, we have the problem, fairly an obvious problem, is that I think some of these container workloads going forward and all that are going to require this, and we're not going to be able to avoid SE Linux forever. But I've also wondered if anybody's investigated whether claims-based ACLs, the DAC, help us at all in this regard.
Container-based workloads are also difficult because there are some things that you simply can't do in containers. People have started discovering that. I'm trying to remember. There's Ralph, I think, has a prototype patch that stores ACLs inside a user namespace area that clients can't then get to simply because of the container problem. Don't know if Ralph is here and can comment on that, but
yeah, I'm here. Sorry. So what were you asking? The namespace issue in the containers?
Yeah, it's the namespace for the ACLs container.
So I think by default it's there's security namespace and there's the system namespace, and I think it's in the security namespace stored by default, and you can configure it, and in the container you can't access that namespace. So yeah, you're basically adding I was basically planning to add an option for the VFS module so that you can configure the xadder name and put it in a different namespace, so basically into the user namespace. Yeah.
This becomes particularly important because, as you know, in the last year, the Linux kernel, not the user space, but the Linux kernel, added support for namespace mapping. So you now have in the kernel, in the VFS, not in user space, the need to support these different namespaces. So it's more plausible that we're going to run into this in the future.